Hello and welcome back to Biology 1620. Today we're going to talk about this wonderful world of archaea and bacteria. We're constantly making new discoveries, discovering new species of archaea and bacteria. Here you see a picture of one of the famous pools in Yellowstone, and recently scientists have isolated a number of new species of archaea from Yellowstone National Park that are living in temperatures of 140 to 176 degrees Fahrenheit. You don't have to go far to see archaea. You can just go to the Great Salt Lake. As you know, the Great Salt Lake is divided in two by a causeway that goes across for railroad transportation. Most of the moisture into the Great Salt Lake comes in to the south arm, not into the north arm. And as a consequence, the north arm has much higher salt concentrations than does the south. And in the north arm, the color is different. And you can see that here in a picture looking on either side of the causeway. That difference is caused by the presence of archaea, which are halophytic or salt-loving. Today, we're going to go through some fundamental topics related to prokaryotic diversity of archaea and bacteria. The take-home message is going to be that they're the most metabolically diverse group of organisms, and they can be found in all environments and all habitats. Part 1, let's talk about the age of microbes. If you begin to look at the tree of life, as we have looked at before, we have Luca down here, and emerging from that, we have the bacterial line, archaea line, and eukaryotic line. What we see is that all three domains include microorganisms, organisms that have but a single cell. So the word prokaryote is not synonymous with microbe. On the other hand, prokaryote will define information related to how the genetic information is stored within a cell. For much of the Earth's history, 80 to 85% of the Earth's history, microbes have dominated. Ever since life was first discovered about 3.7, 3.8 billion years ago, up through 542 million years ago, our planet was dominated by microbes, single-celled organisms. So, to say that they're unimportant is a mistake. To say that they have been around for a long time is certainly a true statement. We can begin to look at it here in our geological timeline again. So here we have the crust forming. First signs of life are at about 3.7 million years, and from 4,000 up to the end of the Proterozoic, this was the age of microbes. They dominated the Earth's surface.